Hi, students and friends. This is your host and teacher Sayyid Ayazuddin Haider, and you are watching Learn and Teach by Sir Ayaz. So, I was doing the paper 0620 May June 2023, and the variant is 41. And I'm done till question number 4. So, I will continue from question number 5. This question is about electricity and chemical reactions. A. The electrolysis of concentrated aqueous potassium bromide using graphite electrodes forms hydrogen at the cathode, bromine at the anode. The electrolyte becomes aqueous potassium hydroxide. 1. State what is meant by the term electrolysis. Now, electrolysis, the word electrolysis is made up of two terms. We have electricity, electro means electricity, and lysis means breakdown. So in this process, there's a breakdown of ionic substance in the molten state or aqueous solution through the passage of electricity. So you write breakdown of an ionic compound in molten or aqueous state by the passage of electricity. Number 2, state why graphite is suitable for use as an electrolyte. Now it contains free electrons because and due to this reason it conducts electricity, and graphite is also unreactive. Conducts electricity and graphite is unreactive. Number 3, write an ionic half equation for the formation of hydrogen at the cathode. So this is the ionic half equation for the formation of hydrogen. It forms from H positive ion. So we have H positive ion plus electrons, and we will get hydrogen gas. Balance the equation. We have to put 2 moles of electrons. Number 4, name the type of particle responsible for the transfer of charge in the conducting wires. The conducting wires are solid substance. In solid substance, the conduction is due to the presence of free moving electrons. So it's electron. Number 5, name the type of particle responsible for the transfer of charge in aqueous potassium bromide. It must be ions. So we have free moving ions in the aqueous solution, which is responsible for the transfer of charge or conduction of electricity in the solution. Number 6, state the names of the products formed when electricity is passed through dilute aqueous potassium bromide using graphite electrodes. So at the anode, we will get oxygen, and at the cathode, we will get hydrogen. At the anode, we will get oxygen. The reason is that we have lower concentration of bromide ion. So that's why we'll get oxygen. The same reason is applicable to the cathode. We have lower concentration of potassium ions than H positive ions. So you'll get hydrogen gas at cathode. B. Bauxite is an ore containing aluminium. Aluminium is extracted by electrolysis of purified bauxite in molten cryolite using carbon electrodes. Number 1, name the aluminum compound in purified bauxite. It is aluminum oxide. Number 2, state 2 reasons why cryolite is used in this electrolysis. Now it reduces the melting point of the electrolyte, which is aluminum oxide here, or it increases the conductivity of this electrolyte, or you can even write it is used as a solvent. So we will write any two from it decreases the melting point or operating temperature. Or it increases the conductivity. Of the electrolyte, or it is used as a solvent. It's acting as a solvent here. Number 3, the anode is made from carbon. Explain why the carbon anode has to be replaced regularly. The temperature is high during the electrolysis of aluminium. So oxygen produced at anode reacts with carbon and it forms carbon dioxide. So we will write carbon reacts with oxygen. Carbon reacts with oxygen and form carbon dioxide. Number C, hydrogen oxygen fuel cells can be used to produce electricity in vehicles. Number 1, write the symbol equation for the overall reaction in a hydrogen oxygen fuel cell. So the overall reaction is the formation of water from hydrogen gas and oxygen. So this will be the equation. H2 plus O2 gives H2O. Let's balance the equation. So I'll write 2 in order to balance oxygen. So we need to write 2 here also. Number 2, state one advantage of using hydrogen oxygen fuel cells instead of petrol in vehicle engines. It produces almost three times more energy than petrol, or you can say more efficient, and it does not produce carbon dioxide. It produces almost 3 times more energy than petrol, or fuel efficient. Or you can write it does not produce CO2, carbon dioxide. Moving to next question. Question number 6. This question is about sulfur and compounds of sulfur. Sulfur is converted into sulfuric acid, H2SO4, by the contact process. The process involves 4 stages. Stage 1, molten sulfur is converted into sulfur dioxide. Stage 2, sulfur dioxide reacts with oxygen to form sulfur trioxide. Stage 3, sulfur trioxide combines with concentrated sulfuric acid to form oleum, H2S2O7. Stage 4, oleum reacts to form concentrated sulfuric acid. A1, In stage 1, iron pyrites FeS2 can be used instead of molten sulfur. The iron pyrites is heated strongly in air. Balance the equation for the reaction occurring when iron pyrites reacts with oxygen in the air. So we have FeS2 plus O2 gives Fe2O3 plus SO2. So if I will balance Fe, so I need to write 2 here, 2 before FeS2. What about S? S becomes 4. Then we have 4SO2. So what about oxygen? We have 4 multiplied by 2, 8, 8 plus 3, 11. 11 oxygen. So this means that if we can take straight away 11 moles of oxygen instead of 5.5. 5.5 is not the whole number. 11 is the whole number. So 11 multiplied by 2 means we have 22 atoms of oxygen must be on the product side. So this should be wrong. And what if I will write 4 here instead of 2? 4 FeS2, then I will have to write 2 here. What about sulfur? 4 2s are 8. 8 2s are 16 for oxygen. 8 2s are 16. 16 plus 2 3s are 6. 6, 16. 16 plus 6, we will get 22. It's balanced now. Okay, number 3, name Fe2O3, include the oxidation number of iron. Fe2O3, what is the oxidation number of iron in Fe2O3? This is a formula for Fe2O3. If you look at the position of oxygen, here it is oxygen, it must be carrying -2, as it is more electronegative than iron, Fe. So I know the oxidation number of oxygen, I can use it to find the oxidation number of iron. There are 2 iron atoms, we have 2x plus 3 atoms of oxygen, 3 multiplied by -2 is equal to 0, as there is no charge on Fe2O3. So 2x minus 6 is equal to 0, or 2x is equal to plus 6, or x is equal to plus 6 by 2. We will get what? 3 plus 3. So the oxidation number of iron is plus 3. So I will write iron 3 oxide. Iron 3 oxide. B. The equation for stage 2 is shown. 2SO2 gas plus O2 gas gives 2SO3 gas. The forward reaction is exothermic. The reaction is carried out at a temperature of 450 degrees centigrade and a pressure of 2 atm. Using explanations that do not involve cost. Number 1, explain why a temperature greater than 450 degrees centigrade is not used. Forward reaction is exothermic. So it must decrease the yield of SO3. This is the reason we can't use 450 degrees centigrade. Because forward is exothermic, it favors low temperature. So it decreases the yield of SO3. Decreases the yield of SO3. Number 2, explain why a pressure lower than 2 atm is not used. So if we decrease the pressure, then it will decrease the rate. So you write decrease the rate. It can even decrease the yield of SO3 also, or decrease the yield of SO3. C. When sulfuric acid reacts with ammonia, the salt produced is ammonium sulfate. Write the symbol equation for this reaction. We have ammonia, NH3, and we have sulfuric acid, H2SO4. The product is ammonium sulfate. What will be the formula of ammonium sulfate? Ammonium ion, this is the ammonium ion, NH4. Sulfate ion, SO4. The charge on ammonium ion is +1, sulfate is -2. Ignore the charges. These subscripts will be exchanged to 1. So we'll get NH4 whole to SO4. So NH4 whole to SO4. Let's balance the equation. Simply put 2 before NH3. It is balanced now. D. Lead 2 sulfate is an insoluble salt. Lead 2 sulfate can be made from aqueous ammonium sulfate using a precipitation reaction. Number 1. Name a solution that can be added to aqueous ammonium sulfate to produce a precipitate of lead 2 sulfate. So you have to take a soluble salt of lead. So we have, what salts we have? We have a chloride, all chloride soluble, except lead, mercury, silver. So this can't be the right choice. What about sulfate? Sulfate, all sulfates are soluble except besan ke laddu. Besan, barium, K, calcium, laddu, lead. So this is also not the right choice. We are left with nitrate. All nitrates are soluble. All nitrates are soluble. So you can take lead nitrate or lead 2 nitrate. Number 2, write an ionic equation for this precipitation reaction. Include state symbols. Now we have to write the ionic equation for the precipitation reaction which is happening between ammonium sulfate and lead 2 nitrate. So lead 2 nitrate, Pb is carrying +2 charge, nitrate -1 charge, 2, 1, ignoring the charges, 1, 2. So it must be PbNO3 whole twice aqueous. What about ammonium sulfate? This is the formula for ammonium sulfate. So I will write NH4 whole to SO4 aqueous. The products we are getting lead 2 sulfate PbSO4 solid plus and ammonium nitrate 2NH4 and O3. So in order to write the ionic equation, we have to open up the equation. Just write down their charges. For Pb, we have Pb +2, it's aqueous, plus 2 moles of nitrate ion, 2NO3 minus aqueous, plus 2 moles of NH4 ion, plus aqueous, 1 mole of sulfate ion, SO4 minus 2 aqueous, gives PbSO4 will remain as it is because it is in the solid state, and 2NH4 NO3, 2NH4 positive aqueous plus 2NO3 aqueous. Remember, spectator ions will be cancelled out. Spectator ions are common ions on both sides of the equation. We have ammonium ion and nitrate ion. So we are left with Pb +2 aqueous plus SO4 minus 2 aqueous gives PbSO4 solid. This must be the final ionic equation. Number 3, the precipitate of lead 2 sulfate forms in an aqueous solution. Describe how pure lead 2 sulfate can be obtained from the mixture. So first of all, you need to filter, then wash the residue with distilled water or even with deionized water, then dry it in air. Filter, wash the residue with distilled water, then dry the residue, which is a crystal, in air. Moving to next question, number 7. This question is about organic compounds. A. Butane reacts with chlorine in a photochemical reaction. This is a reaction. C4H10 plus Cl2 gives C4H9Cl plus HCl. Number 1. State the meaning of the term photochemical reaction. The reaction uses ultraviolet light. Number 2, an organic compound with the formula C4H9Cl is formed when one molecule of butane reacts with one molecule of chlorine. Draw the displayed formula of two possible structural isomers with the formula C4H9Cl formed in this reaction. So you have to draw the isomers, possible isomers for C4H9Cl. So there are 4 carbon atoms. So either chlorine is placed at carbon number 1 or carbon number 2. So you can have either 1 chlorobutane and 2 chlorobutane. It's only the position of chlorine that is different in both. We have 4 carbon atoms, 1, 2, 3, 4. So chlorine's at carbon number 1. It's up to you whether you want to place it on the right hand side or on the left hand side, but should be on the first carbon. There is chlorine. Let's saturate the carbon atoms with hydrogen. Place hydrogen. What about 2 chlorobutane? Again, we have 4 carbon atoms. 1, 2, 3, 4. We must have chlorine at the second carbon. So here is chlorine. Now saturating the carbon atoms. B. The structure of compound A is shown in figure 7.1. This is the structure of compound A, figure 7.1. Number 1, deduce the molecular formula of compound A. Molecular formula. So we have C, hydrogen and oxygen in it. C, hydrogen and oxygen. Let's count the number of atoms for each element. For carbon, 1, 2, 3, 4. So this C4. Hydrogen, 1, 2, 3, 4, 5, 6. H6. What about oxygen? 1, 2, 3. So C4H6O3. This must be the molecular formula of compound A. Number 2, there are 3 functional groups in compound A. Name the homologous series of compounds that contain the following functional groups. Carbon-carbon double bond, it's present in alkene. So I will write alkene. OH is present in alcohol. COOH is present in carboxylic acid. Number 3, state what is observed when compound A is added to aqueous bromine, aqueous sodium carbonate. Now, aqueous bromine decolorizes if there is carbon-carbon double bond present in it. So you can even write decolorize, decolorizes or turns colorless. What about aqueous sodium carbonate? It reacts due to the presence of this COOH, the carboxyl group, acidic group. So we'll have fizzing or effervescence, fizzing, bubbling. Number 4, compound A can be used as a single monomer to produce two different polymers. Draw one repeat unit of the addition polymer formed from compound A. We need to draw the addition polymer formed from compound A. For your convenience, I am drawing the monomer. We have COOH, C double bond, CH, and here we again have H, and we have CH2OH. Now I need to draw repeat unit of this addition polymer. So repeat unit, in order to draw the repeat unit, exclude this double bond. So addition reaction, so this bond will be removed and you have only single bonds. COOH, H, CH2OH, H. Here we have single bonds in order to saturate it. So this will be the final repeat unit of the addition polymer formed from compound A. Number 5, compound A can be converted into a dicarboxylic acid. Name the type of condensation polymer formed from a dicarboxylic acid and a diol. It must be polyester. That's all for this video. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.